Okay. Well, so the position of an object moving along x-axis is given by x equal to a plus bt square, where a is 8.5 meter and b is 2.5 meter per second square, and t is time in second. So we are given an equation for x. X means position. What is the equation? A plus bt square. So some object might be moving in such a way on a straight line that its position changes with time. As t will change 0, 1, 2, 3, 4. As time will change, position will also change. If you put the value, you will get how it changes. What's the value of A? 8.5 plus 2.5. And these are constants. A and B are constants. That is, they have a fixed value. But T is not a constant, obviously. As something moves, obviously T will change and will pass. So when time will pass, the value of T changes. Right? So T is variable, but A and B are constant. We can put their values directly. They don't trouble us at. So this is the position. Now read the question further. What do we have to find? What is the velocity at t equal to 0 second and at t equal to 2 seconds? So velocity at t equal to 0 and t equal to 2 seconds. Okay. Which velocity has been asked here? Average velocity, instantaneous velocity. Average. But aren't we given an interval? An interval is from this time to that time available? Yes or no? No. Yeah, it is instantaneous velocity at this time and at this time. You agree with that? Yes. I hope that is clear. So we have to find at this time what's the velocity, and we have to find at this time what's the velocity. So how do you find velocity from position? How do you find velocity from position? V vector is equal to dx upon dt. Okay, so let's do differentiation first of all. Therefore, v vector equal to d by dt of x. What is x? 8.5 plus 2.5 d square. Okay or not okay? So first of all, we see that there is addition here. Correct or not? Yes. Not very there. So we use which rule? Addition or subtraction rule. Okay, so d by dt 8.5 plus d by dt 2.5 into t square. Got it? Yes or no? Yes. Sure? Yes. Okay, Mantra, what will be our next step? Come on. Fast. અહીંયાથી ચાલુ કરો આ શું છે?
The 8.5 is once
outside. Okay, then what will you write here? If you put 8.5 outside. કઈ નહીં લખો. Empty bracket એવું લખી. So this one can be solved by which rule? Refer the list of the rules. You can also do it, Mantra. Everyone can do it. Refer the list of rules. Rules याद રાખવા એટલે જરૂરી છે. મજાક નતો કરતો કે યાદ રાખજો.
It is 0.
It is 0. Very good, because this is completely a constant. The differentiation of constant is 0. Plus, sit down, Mantra. Somehow, what should we do here? 2.5 outside. So what should I write? You just tell me what I should write. Hurry up.
0.
See the 0 or not?
Yes.
Does it match with that exactly? Is this whole thing a constant? No, this is a constant multiplied by something. Yes or no?
Yes.
So keep the answer out. What should I write? What should I write?
0.
પાછું 0 ક્યાંથી આવી ગયું? It will be 2.5 dt square by dt. Yes or no? Taking the constant out. Got it? Compare it with what we have, a into u. So keep k outside. So 2.5 outside and remaining just like that. Understood? Okay. So this is equal to now 0. 0, no need to write that. Yeah. 2.5 into. Who can tell me what's this? Raise your hand. dt square by dt. What will that be? dt square by dt. Yes, Cyril. 2 into t raised to 1. Very good. Okay, using the first rule. So this is going to be 5 into t. Alright? So the velocity will be 5 into t. Okay? If anyone has questions, you can raise your hand. If velocity is 5 into t. What is t here? Time. Okay, t is the time. Now this is the general expression for velocity, that any time t velocity will be like this. So now if I want to find velocity at t equal to 0, then what will I do? I'll put value of t. How much is the value of t for this one? 0. So what will be the velocity? 5 into 0 is how much? 0. 0. Very good. So velocity at t equal to 0 is 0. Do you understand? Sure. Okay, let's go to the next one. At t equal to how much? 2 seconds. How much would be velocity at t equal to 2 seconds? 10. Clear or not?
Yes.
Fine. The velocity at t equal to 2 seconds is 10. Any questions? See, I'm not asking that for formality. I'm just trying to, encourage you to ask if you have anything. Anyone? Okay. Right. There is something more to be found also, I think, in this question. Let's read it further. It says, what is the average velocity between t equal to 2 and t equal to 4? Okay, so now we actually have to find average. So, what's the formula of average velocity? Delta x upon delta t. But delta x actually means x2 minus x1 upon, and then here t2 minus t1 is the denominator. So I think we are given the initial and final time. We have to find it between which time and which time? T equal to 2 seconds and t equal to 4 seconds. This is t1 and this is t2. Yes or no?
Yes.
Okay. Fine. So denominator should be clear to all, I'm sure. Let's find out x2 and x1. Now what this means is, when the time is 4 seconds, what's the position? So when the time is 4 seconds, what's the position? So I can say x2, that is final position. x2, that is final position, will be 8.5 plus 2.5 into 4 square. Raise your hand if you understood that. Okay, very good. Not clear? What is meaning of x2? Final position means at which time? At 4 seconds. So if I want to find x means position at 4 seconds. So what should I do to this expression? Put t equal to 4. Is that clear or not? Because we are finding the position at which time? At 4 seconds. Understood?
Yes.
Okay or not okay? Right? We want to find the value of x, value of position, and when the time is 4. Find the value of position when the time is 4. So that's why I put this. So let's see what this will turn out to be. 8.5 plus 4 square 16. 2.5 is 40. So this is going to be 48.5. Clear? Now just like that, initial position. Initial position means x1. It was at which time? Initial position was at which time? At 2 seconds. So we are going to put it here. So find it quickly. You have 10 seconds. What is x1? x1 is how much? 8.5 plus 2.5 into 2 square. 2 square is 4. 4 into 2.5 is 10. 18.5. Clear or not? So have we found x1, x2? Yes. Initial and final position both. Can we put all the values here? So we can find out what? Average velocity. Do it. Done. Done. x2 is 48.5. x1 is 18.5 upon t2 minus t1 is 2. So this is 30 by 2. That is 15 meter per second. આ સ્પીડે હવે ચાલશે ફિઝિક્સ. ઓકે, હું તમારી રાહ નહીં જોઉં. તમને આવડે તો બરાબર, ન આવડે તો પછી એક લિમિટ થી સ્લો ન જઈ શકાય. So you are free to ask questions whenever you have. નહીં તો તમે નહીં પૂછો તો હું આગળ જતો રહીશ. Okay? All right. Any questions? Fine. So example 3.2 is this. Now let's go over to the next. That is finding velocity from xt graph. Okay, so xt graph and velocity. So earlier we have learned finding average velocity from xt graph. Yes or no?
Yes.
Who remembers how do you find average velocity from xt graph? Yes, Prisha.
So that x2 minus x1 upon t2
T2
minus
minus
c1.
C1. Then what we find, what is that called in language of mathematics?
The final post.
એવું નહીં એને ઈ તો ગ્રાફ વગેરે થઈ જાય ને x2 minus x1 t2 minus c1 તો ગ્રાફ વગેરે કરતા. But from the graph if you want to do it, yes, it louder. Tan theta, yeah, tan theta, that is slope of chord. Okay, sit down, better. So earlier we have learned that if you want to find average velocity from xt graph, so this is some shape graph, okay, anything, no problem. Whatever shape, the logic works. So this is some xt graph, and we want to find out what is the average velocity. Then what we were doing is like we take 2 times t1, that is initial time, t2, that is final time, and between them we have a time interval delta t. So if you then draw a chord, yeah, if you draw a chord, okay, then the slope of that chord gives you tan theta, and that is the average velocity, right? But now we are not trying to find average velocity, we are trying to find instantaneous velocity. Suppose someone will say, what's the velocity at a particular point of time? Here, when time is t, at this time t, how much is the velocity? Now we don't have a scope of drawing a chord. Why? Chord draw કરવા માટે interval જોઈએ. I hope you get that. If you want 2 points, then that's a chord, right? But here we have only 1 point. With 1 point you cannot draw a chord. I hope you get that. But the idea is still fairly similar. Have a look at how it works. Do you remember that for average velocity the time interval is big, and if you want to get instantaneous velocity, then you should make the time interval smaller and smaller and smaller and smaller. That is, you should basically try for delta t tends to 0. So as you make the time interval smaller, do you realize that these 2 points A and B will come close? So ultimately what will happen is that they will come so close to each other that the chord, that chord will shrink, and finally it will become a tangent. Think about that. Chord ne તમે આમ move karta jao. Then this line, first of all it was this line, yes or no? This line is not a tangent, but gradually as these 2 points come closer, ultimately both points will become 1. So at that point that chord will become tangent. Did you understand? So simply speaking, here is it. Velocity is equal to, we already know it is dx by dt, and that will also be equal to tan theta now, but this time it's not the chord but rather the tangent. So wherever you want to find it, you draw tangent. Suppose you want to find velocity at t equal to 1 second, then you draw tangent here. If you want to find velocity at t equal to 2 seconds, then you draw tangent here. Did you understand? Okay, so wherever you want to find the velocity, you draw a tangent over there. And the slope of that tangent, every line has a slope. If this line makes angle theta with positive x-axis, or on the right hand side this angle is theta, then tan theta will be the slope of suppose this is some randomly shaped x. એક બે કરીએ તો તમને પ્રેક્ટિસ થઈ જાય છે કરવાનું. If you would consider a couple of points, let's say A here, let's say B here, and for example C here, and let's say D here. So this is xt graph. So there are 4 points, A, B, C, and D. If we want to find out the velocity, for example, at the point A. If I want to find out what is the velocity at this particular time, whatever that might be. Suppose 1 second, this is 2 seconds, this is 3 seconds, and let's say this is 5 seconds. So suppose I have to find out what is the velocity exactly at 1 second. So that is instantaneous velocity. I cannot draw a chord. So what will I do? I will take 2 points that are very close to each other. That is basically I am making a tangent. Then I will check or find out the slope of that tangent by finding tan theta. First I will get theta, then I will find tan theta. So here, if I draw a tangent at A, આવડે કે નહીં tangent draw કરતા કોઈ પણ point પર આવું આવશે ને? Yes or no? Sure. Okay, just to make you recollect it. There are 3 lines. Which line has maximum slope out of 1, 2 and 3? 3. 1 has 0 slope. Is that okay or not? 1 has 0 slope, 2 has more slope than that, 3 has even more slope. But what about this? Does the 4th line have slope?
Yes.
Yes, but that's called a negative. What is it called? Negative. Why negative? It's basically simple. If the line is going up on the right side, the slope is positive. If the line is going down on the right side, the slope is negative. That is, as you start going towards right side, if you have to go up, that's a positive slope. If you don't have to go up, don't have to go down, that means 0 slope, horizontal. And if it's like this, that's a negative. Okay? Make sure you remember this. Now, so here is A. Does the tangent at A, this point, tangent at A, that is at 1 second, does it have a positive slope or negative slope?
Positive.
Got it?
Yes.
Fine, so it will have a positive velocity. But if you look at D, try to draw tangent at D in your notebook, what it would look like. Draw કરવાની practice તમારે કરવી પડશે. હું તો બોર્ડ પર કરીશ. You have to do it in your notebook. Done? It will look something like this, yes or no?
Yes.
So at the point D, the velocity will be 0 because this line is making 0 angle with the horizontal. समझ पड़ेगा ना? This line is making 0 angle. So tan 0 is 0. Okay, tan 0 is 0. So that's why the velocity at D will be 0 because the slope of tangent is 0. But if you go to B, tangent arm also, yes or no? So there the slope is negative. So here the velocity of velocity of the particle at 3 seconds will be negative. What is meaning of negative velocity? The particle is moving towards the negative direction or towards the left direction generally. Is that clear? Yes or no? લખેલું છે. બરાબર ને? લખેલું છે ને? Okay. Then what happens at C? What happens at C? You draw a tangent. Out then almost. Yes or no? Sure. So at C, the slope is 0. Okay? Aditya, stand up please. At which points out of these the slope of tangent is 0? Out of the 4 points that you can see A, B, C and D. Yes or no? At which point is the slope of tangent 0? C. At C. Anything else? Sure?
Yes.
Absolutely?
Yes.
It would be if you watch inside the class more than outside. Okay? At D also it is 0. Sit down. હવે આટલું જ કહીશ. Okay, I think I waited for you all patiently to get started, to go along with me. આટલા બધા દિવસ રાહ જોઈ, તમને પૂછ્યું, તમે વાંચો છો, I'm waiting. But now I'm running out of patience. હવે એને જ ભણાવવામાં આવશે જે ભણે છે, બાકીના ભલે બેઠા. Alright? આવડે તો બરાબર, ન આવડે તો વધુ સમજ. Yes or no? Okay, so make sure you are active, only then you would be benefited. Otherwise, you'll sit here, you'll spend your time and we'll know what happened there. Okay. So we have A, D, B and C. These are 4 points. So like this you can draw tangents everywhere and then decide based on that whether the particle has a positive velocity or a negative velocity. How do we decide? If this is positive, going up towards that side. This is horizontal, zero slope. Going down like that, negative. Understood?
Yes.
Sure?
Yes.
Okay, fine. So that's how you find velocity from which graph?
X
graph. Is that clear? That's how you find velocity from x. Okay, fine. Again, slope of the tangent at whichever point you want to find velocity. Right? Average velocity, slope of chord. Instantaneous velocity, slope of tangent. And in which graph? Yeah, that's also right. Of which graph? Of x. Because later on we are going to study more number. Okay, other graph, VT graph and all. Fine. Let's go over to the next thing. That is average acceleration. Average acceleration. What is the general meaning of acceleration? Acceleration is telling you how quickly velocity is changing. That's the general meaning. Velocity is telling you how quickly position is changing. If I have more velocity, then I will be going from here to there very fast. That is, my position will change quickly. But if I be going very slow, then my position will change, but it will take a lot of time. So velocity tells you how quickly position is changing. Acceleration tells you how quickly velocity is changing. Clear? Acceleration tells you how quickly velocity is changing. So first of all, average acceleration. To understand what is average acceleration, it's actually very simple. Do you remember what is average velocity? It is delta x by delta t. That is, in some given time interval delta t, how much is the displacement or change of position? Just like that. Average acceleration is first of all written like this. Clear or not clear?
Yes.
Simple. See, we are so consistent with simple. एक symbol आवड़े तो બધા आवड़े जाए. Average. A for
Acceleration.
vector is for the vector, right? Okay, the sign is for the vector. Clear? So A vector is delta V vector by delta T. Okay, delta V vector, that is, it is the ratio of change of velocity. Change of velocity means delta. Okay, to the time interval. Ratio of change of velocity to the time interval. Definition करता formula વધારે use. Okay. What will be unit ये जोइए. Change of velocity will be meter per second, and this will be second. So the unit will be meter per second square. This is the vector, right? Acceleration. Sorry, average acceleration is a vector. Now, just like there is a relation, I mean, the way the pattern is for average velocity, and then there is a instantaneous velocity. There must be difference. It's just that you take that time interval and take delta t tends to 0. Yeah, this is to come. Sit over there, sit over there. There are so many places. This is the worst place to sit at. Okay, यहाँ से कहीं देखा इसने कोई चीज़. So, if you see what was average velocity. If you see, this is average velocity, and similarly from that we can relate instantaneous velocity by making the time interval smaller and smaller and smaller. So we wrote something like limit delta t tends to 0, delta x by delta t, and then we said that when everything becomes very small, we can say infinitesimal are there. Dx is infinitesimal displacement and dt is infinitesimal time interval. Okay. Okay or not okay?
Yes.
So that would mean just like that in case of instantaneous acceleration. Again, nobody likes to say the word instantaneous. So whenever someone says acceleration, it automatically means which one? Average? No. Instantaneous. Is that okay? Acceleration means instantaneous. બોલાના જેવું છે એમાં કંઈ વધારાનું સમજાવવા જેવું નથી. A vector equal to limit delta t tends to 0, delta v vector by delta t. What I mean to say is, when you take the velocity change over a big interval from t1 time to t2 time, you get average acceleration. But now, just like we asked a question earlier, how quickly velocity is changing at a particular time. Instantaneous velocity is there. How much or how far the vehicle moves between 4 and 5, that is average velocity. Just like that, if I ask how much is the velocity changing between 4 and 5, that is average acceleration. Okay, just like that, if I ask exactly at 4:30, how quickly is the velocity changing? I said exactly at 4:30, how quickly is the velocity changing? I am not putting interval, I am saying at. So when you want to do that, you will have to take limit delta t tends to 0. Just like we did it over there. It's a logic, there is nothing new here. The only difference is in velocity it is delta x by delta t, because velocity is related with change of position, but acceleration is related with change of velocity. So that would be delta v vector by delta t. હવે આને ઓલા ફોર્મમાં લખો તો શું લખાય? dv vector by dt. Did you understand? હવે પૂછે what is the formula of acceleration? Then this is the one and only correct formula of acceleration. A vector equal to dv vector by dt. A vector is dv vector by dt. Okay. So what this means is as follows. If I write a vector is equal to d by dt. Now what is v actually? V vector is dx by dt. Yes or no? Did you understand what I have written? Yes. I repeat. A bracket is there. V vector is a velocity. Yes. So a vector equal to d v vector by dt. Okay. Now this kind of ugly symbol is not used. Okay, this is not wrong, but there is another symbol for this in mathematics. Okay, what this really means is as follows. You do differentiation of x with t. The answer આવે પાછું કરવાનું ને second time. I hope you see what I am saying. Look at the change. X એનું differentiation કરો તો dx by dt, that is called v. પાછું એનું differentiation કરો તો dv by dt, what is that called? A. Acceleration. So what I am saying is, if you take x and you do differentiation one time, you get velocity. Is that okay? And you do differentiation one more time, what do you get? Acceleration. Clear or not? Yes. So if you take position and you do differentiation twice, back to back, again I will say 3i4. चलो બે વાર સ્ક્વેર કરો. Squared, squared. Understood? Yes. એક વાર કરવાનું પછી બીજી વાર કરો. So if you do the differentiation of x one time, you get velocity, and if you do it one more time, you get acceleration. समझ पड़ गई ना? Okay. So this thing in mathematics is called second order derivative. Okay. It is called second order derivative. Word मतलब कोई देवला क्या है? Acceleration is the second order derivative. Acceleration is the second order derivative of position. Acceleration is the second order derivative of position. Okay. And the formula ni જેમ લખો હોય તો આવું લખાય. But to be very frank, you cannot use it. What I mean to say is તમે directly no કરી શકો. Here if someone says square 3 2 times back to back, the procedure is only this way. First you square it, then you square it one more time. એમ જ થાય ને? એક સાથે બે વાર સ્ક્વેર કરતા ન આવે. Correct or not? So just like that, if someone says acceleration is d square x by dt square, a symbol no meaning so this symbol means this second order derivative. What does that mean? You do differentiation of x. How many times? 2 times, back to back. You do differentiation of x 2 times. एक बार करो तो velocity आएगा, जी एक बार करो तो acceleration. Did you get that? Okay. So this symbol, it's a mathematical symbol. आने के physics आज लेवा जाना. This mathematical symbol means do differentiation 2 times back to back. ખાલી એકવાર આવું dx by dt લખો તો do differentiation how many times one time અને d square upon dt square એવું લખો તો two times અહીંયા 3 લખો તો 3 times પણ એટલું બધું આગળ સુધી આપણે નહીં આવે ઓકે so d square x by dt square that is what gives you acceleration. That is acceleration is the second order derivative of position. Okay, fine. So you can remember it. Okay, go for nana eva MCQ ma use થઈ જાય ક્યાં. Okay, but generally you have to go in two steps. First from x you find v and then from v you find a. Alright? Any questions? Okay, let's solve one related to all this. So suppose I tell you that position of some object is, let's say, 5t square minus t. Okay, suppose 5t cube minus t square. If someone says that position of some object is 5t cube minus t square, just like the example we solved, x value is given. Now based on that, what do we have to find? First one, find velocity at t equal to 3 seconds, and second one, find acceleration at t equal to 2 seconds. Okay, we want to find velocity and acceleration at different times. This is in meters, so all answers will be in SI units only. X is given, position is given. From position, how to find velocity? V vector equal to dx by dt. Okay, differentiation of position with respect to time. Clear or not?
Yes.
What is our unit?
Yes.
Okay, for differentiation. Chalo, you have 1 minute. Use all the rules that you know. Done? Yes or no?
Yes.
2 hours.
5t into 3t square minus 2t.
Simplify the કરો તો શું આવે?
15 minus
15t square minus 2t. Yes or no? Okay, using all the rules. 15t square minus 2t. Anyone any questions here? નહીં ને? તો વાંધો નહીં. હોય તો પૂછી લેજો. Okay, now this is v. We have to find velocity at which time? At which time? At t equal to 3 seconds. So at t equal to 3 seconds, velocity will be 15 into 9 minus 2 into 3. Okay, someone? Hello, Jesse. 129. बराबर ने 129 meter per second. Okay. So next, the second thing is what do we have to find? Acceleration. At which time? At 2 seconds. पहला तो formula आपने नंबर है. So a vector equal to dv vector by dt. See, you cannot do differentiation of this. એમનો કે સર velocity is 129. Let's do it differentiation. Answer is 0 આવશે અને mark છે 0. Is that okay?
Yes.
If you want to do differentiation, you have to do it before putting values. I repeat. In general, you can never put values before doing differentiation. Did you understand? You can never put values before doing differentiation. So for example, here we have put values. So now you cannot do differentiation of this. If you do it, already you have put value, so now everything is a number. Yes or no? Once you put value of t, everything becomes a number. So the પછી answer 0 જ આવે ને. So that's wrong. અહીંથી start. Did you get that? Here we have not put the value, so we can do differentiation of this. Follow chalo. d by dt of 15t square minus 2t. So આવે રૂલ્સ બધા છે તમારી નોટબુકમાં જોઈ લેવાના, યુઝ કરી લેવાના, whichever is applicable. ન સમજ પડે તો પૂછી લેવાનું. થઈ ગયું? મળતી આન્સર 30 ખાલી 30 બીજું કઈ આગળ પાછળ આવે. $30t minus 2. 30t minus 2. When you kick 2 out, dt by dt will remain. બરાબર ને? When you kick 2 out, dt by dt will remain. જો હું તમને ચાન્સ આપું છું, કોઈ મને પૂછતા નથી, પછી એમ ન કહેતા કે હવે નથી આવડતું. રેકોર્ડ એ થાય છે, જોઈ લેજો. ઓકે?
30t minus 2 that t will be 2t.
ડિફરન્શિએશન માં dt માં 1 ન થઈ ગયો. ચલો સ્ટેપ લખાવ, ચલ મંત્રો બધા. એક વસ્તુ તમે બધા સમજી લેજો, તમારે શીખવું હશે ને તો તમારે જ કામ કરવું પડે. સોરી 15, કીધું 15 ઇઝ કોન્સ્ટન્ટ. સૌથી પહેલા એ રૂલ જ આવશે, સૌથી પહેલા એ રૂલ નહીં આવે. ફર્સ્ટ ઓફ ઓલ એડિશન સબટ્રેક્શન રૂલ. સો d by dt 15t square minus d by dt 2t. ઓકે, ચાલો પછી
d by dt into 15 into 2t.
15 into 2t. ચલો એ આવડી ગયું. પછી અહીંયા
2t
2. જ્યારે ડાયરેક્ટ નો આવડે ને તો લખી જ કરો, સિમ્પલ રૂલ. હું તો આવું નહીં, આનાથી ઘણું કોમ્પ્લિકેટેડ હોય તો એ પેન વગર કરી નાખું, બટ યુ આર સ્ટીલ લર્નિંગ. તો તમને જ્યારે ન ફાવે ને ત્યારે સ્ટેપ્સ લખો. તો if we put 2 outside, what should I write now? આટલે બહાર મૂકો, બીજું શું લખવાનું પછી અહીંયા dt by સમજ પડે કે નહીં? kick the constant out નો મીનિંગ શું છે? write 2 outside, બાકી બધું એમ ને. અહીંયા જો, અહીંયા જય, અહીંયા જો તે હા dt by dt, how much is dt by dt? 1 થઈ ગયું ને? તો શું આવી ગયું? 15 into 2 30 minus 2 into 1, which 1 is 2. Clear? 30t minus 2. Got it? Are you there? Okay, so this is acceleration. Now we have to find it at which time? We have to find it at which time? At t equal to 2 seconds. So what? Therefore, at t equal to 2 seconds, acceleration is 60 minus 2, that is 58 meter per second. Got it? Yes or no?
Yes.
હવે તમને સમજ પડે છે કેમ મેં આના સમ આપ્યા હતા 3 કરવા, પણ આપણે કર્યા નહીં. બરાબર ને? તો હવે તમે આવી રીતે જ રાખશો તો હું આવું જ રાખીશ. તમને શું લાગતું હતું? એ મારી નેચરલ સ્પીડ હતી ભણાવવાની, હમણાં ધમધમાવી તો ક્યારે પૂરું થઈ જશે ખબર નહીં પડે તમને લોકો. હું તમને તમે 9th સ્ટાન્ડર્ડ ના છો એવી રીતે ભણાવતો હતો, પણ તમે પછી કંઈ કરો જ નહીં તો 9th સ્ટાન્ડર્ડ ક્યાં સુધી ચલાવવાનું તમારે? બરાબર ને? ફોર્મ્યુલા પૂછીએ તો ન આવડે, રૂલ્સ પૂછીએ તો ન આવડે. હોમવર્ક ના 3 સમ આપ્યા નથી કર્યા ભાઈ, કેમ? 3 સમ ન કરો તો આ બધું ક્યારે કરશો? હવે તમારી રાહ જોવાની નથી. If you will ask me question, I will help you out of it. Right? And without any kind of hatred. ये તમે સમજી લો. But I will not put in any extra effort. બરાબર? તમારે જ્યાંથી જેની પાસે શીખવું હોય, you are free to learn. But I have decided that my time, my extra time is not worth that much if you don't put your effort. એટલે જે મહેનત કરશે એના માટે હું વધારાનો ટાઈમ આપીશ, નો પ્રોબ્લેમ. રિસેસમાં સોલ્વ કરાવીશ ડાઉટ તમે આવશો, 2 લેક્ચર વચ્ચે સોલ્વ કરાવીશ. ઓકે, Not at all. Okay, some important points about acceleration. First one, change of velocity is always in direction of acceleration. Now, second one, acceleration may be positive, negative or zero. Three possibilities are there. Right? And what does the sign of acceleration indicate? Direction, because acceleration is a vector. Okay or not okay? So acceleration may be positive, negative or zero. Right? So positive, negative, right hand left side 0. If acceleration is 0, then velocity is constant. If acceleration is 0, then velocity is constant. So simple then. Maths will help you. Okay, what's the meaning of or definition of acceleration? dv vector by dt. This is equal to 0. If something is there, dv by dt is there, and if differentiation is 0, then ask yourself a reverse question: whose differentiation is 0?
dv.
Look at the rules of differentiation. We have one rule where differentiation of something is 0. Differentiation of what is 0? Constant is 0. Differentiation of constant is 0. Is that okay or not okay?
Yes.
So that means here if dv by dt is 0, that is only possible if v is constant. Okay, so that its differentiation always turns out to be 0. So this is the case, right? એટલે આ બધા તમને તમે એનું ઇમ્પોર્ટન્સ સમજો ન સમજો I don't know really. Okay, but everything here is connected. એકનું આગળ પછી આવા જ કરે છે. So this is very common pattern. એટલે જ આ બધું યાદ રાખવું જરૂરી છે. મેં કહેશો કે અમે વાંચ્યું નથી, અમને નથી આવડતું એક દિવસ, તો પછી આગલા દિવસે એ આવશે ત્યારે નહીં સમજ પડે. Then you cannot expect to understand. એના જેવું છે જેને ABCD ન આવડે એને તમે સેન્ટેન્સ લખતા શીખવાડી શકો. કરજો જો ટ્રાય કોક દિવસ. ચેલેન્જ. તો અહીંયા એવી જ સિચ્યુએશન મારી છે. I hope you understand. કે તમે એમ કહો કે સર અમને કાલનું નથી આવડતું, વાંચ્યું નથી, તો હવે આજનું કેવી રીતે મારે તમને સમજાવું? હું ગમે તે કરીશ તમને ખબર જ નહીં પડે. ગેરંટી હું જ આપું છું, ગેરંટી હું નહીં, તમે ગમે તે ફિઝિક્સ ગમે તેને ફિઝિક્સ ભણાવવા બોલાવી લો. ઇટ ઇઝ નોટ પોસિબલ. આ તો હું હજી તમને કહું છું કે જો આવું આવ્યું હતું, બીજા તો સીધું મોઢે જ કહી દેશે કાલનું કેમ નથી આવડતું, કાલનું શીખીને આવો પછી આવજો. ઓકે, so acceleration is 0, velocity is constant. That's what we have. Next, it was background rule. अच्छा, हमारे कल लग. Such motion. Okay, this is something that you have learned in 9. Such motion is called uniform motion. याद आया क्या? Uniform motion. Uniform motion means velocity remains constant. Okay, and we can also say that such velocity is called constant or uniform velocity. Such velocity is called which velocity? Uniform velocity. Basically, meaning of uniform velocity is that velocity does not change. Meaning of uniform velocity is that velocity does not change. Alright? Fine. So let's stop at this point here. We'll write down a few more points in the next one. Once that is, this is what I will do.